So a slightly different type of question. Now we have 4 different compounds, and we need to rank each one in terms of how stable it is. Some compounds will be very stable. You can leave them sitting out forever and they won't change. Sugar, salt, those are some typical examples. Other compounds will react quite easily and quite readily just by sitting around. Any of the alkali metals, things such as lithium, sodium, potassium, those ones, those react so quickly and so easily that they're highly unstable. So to do this, we need to know what the delta H values of each of these compounds are, and that's where the thermochemical data table comes in. It's in your data booklet. It is a long table. It's got 3 columns. The good news is most of the compounds are listed alphabetically. The bad news is that not all of them are, so it will take a little bit of searching to find them. But if we go and we look up the delta H values for each one, if we go and we look up CO2, it has a delta H of negative 393.5, and the units of delta H is kilojoules per mole, which you can see at the top of that table. MgO, delta H is negative 601.7 kilojoules per mole. NO is positive 90.3 kilojoules per mole. And NH3, negative 46.1 kilojoules per mole. And that's all the information we need to determine which is the most stable and which is the least stable. So going back to endothermic versus exothermic, we have 3 compounds that when they form are exothermic: CO2, MgO, and NH3. Those compounds release a lot of their energy to the surroundings, meaning that they exist at a low energy state, and in a way that's more stable. Think of it this way. You go and you eat a whole bunch of sugar, you start getting hyper, you're at a high energy state, you are unstable. Once you eat that sugar, you go for a run or you go do something to burn it all off, you sit there, you don't do a whole lot, you're at a low energy state. So these compounds that are at a low energy state, these are the most stable. So the lowest energy would be the most negative delta H, which would be MgO. That would be our most stable compound. And we have one compound that is endothermic when it's formed, so it needs to take in energy in order to form. It exists at a higher energy state, meaning it's highly unstable. So NO is the least stable compound of this list.